So, let's start talking a little bit about collections and generics. Arrays are cool, right? They're actually really, really cool. They let me keep a bunch of things of the same type, right? I can't do that. No? Arrays let us keep a bunch of things of the same type, right? You can keep a bunch of strings or a bunch of person, a bunch of point, a bunch of whatever you have, right? If you notice, they are special. They are a class, right? Once you create an instance, they're just a class. They have methods and fields and properties and stuff like that. But they are special in a couple of ways. First of all, they have a special operator, the bracket, right? Also, they have a weird type, right? They have a type that's derived from other types. You have int, you can have an int array. You have person, you can have a person array, right? So they allow us to create new types. Does that idea make sense? Now, so arrays are cool. They also suck. Why do they suck? Well, first of all, they have a static size. They can't grow, right? And second, your keys have to be integers and they have to be in a sequence, right? You can't have only the odd element of an array, right? Only 1, 2, 1, 3, 5, 7, 9, right? Does that idea make sense? So we have two main extensions of arrays. And in general, we call those collections. One extension is going to allow us to grow the array and add and remove elements from it. My indices are still integers and they are still in sequence. So if I have 10 elements, I know that they are numbered 0, 1, 2, 3 until 9. Does that idea make sense? The generic thing is called a list, and we'll see. The other thing is a map, which allows me to have whatever I want as my key. So I can have strings as my key. I can have people as my key. Does that idea make sense? With this, I lose the ability of, I lose the nice thing that my things are numbered and go from 0 to 9 or something like that, because once you have strings, there is no good way of enumerating all the strings, right? Not terribly useful. Now, in Java, they invented a different thing for this, creating types from other types, and that is called generics. So just like with your array, you have an array of ints, and an array of floats, and an array of points. Here we are going to have the ability to have a list of int or float or whatever. This is different. Arrays are kind of built into the language. This is a general mechanism. So we will see, although you don't have to learn it for passing this class, how to create those things if we want to. But this syntax is slightly different. You put the generic class and then you put the type inside angle brackets, less than, greater than. So if we want to create a list of strings, we will do list of strings. There is also one other important thing, which is interface versus implementation. For this list, the obvious is there are several different implementations. You will see in data structures one of the obvious implementations. It actually sucks. It's a linked list. It sucks for most applications, but it sort of works for some, and it's very simple to understand. In fact, we did a linked list, right, as one of the examples when we were doing classes, right? But performance tends to be terrible. The other obvious one is with an array list, and that is the one that most people use. C++ calls it a vector. In Java, there used to be a vector class. Now the preferred one is the array list. You don't terribly care, except that you probably want to use list as your interface and array list as your implementation. For maps, which we'll see later, we'll see again there are two main implementations, one using trees and the other one using hash tables. So, what can I do with a list? I can do add, and that allows me to add an element. Instead of the square brackets, I have get, and I pass it an int for the index, or set, where I pass it an index and an element. And then you would expect to have a length. We don't have that, we have size. And it's a method, not a property. Just because if we were consistent, it would make it easy for programmers. We don't do that. And we have isEmpty and remove, and we can do iteration with the for each loop. So, what can we do? What does this stuff look like? Public, static, void main. I can do list of string words equals new and make this guy, this is option this, Java, yes, that's what I want. And then or actually maybe word. Hopefully it runs. Yay! And it ran the other guy. Why? You horrible thing. Run. Edit configurations. Yeah. Okay, now it should work. Shift F10 on the Mac. Ah. What happened to you? Something got really, really wrong. Let me just delete all the code. Try to compile it. Yeah, it's broken. This horrible thing doesn't know what to do. Ah, what's main? It's like this, right? This horrible thing knows what to do. It's me who is an idiot. Which tends to be the standard result when you're fighting with the compiler, right?
Yeah.
It could be wrong, but it usually isn't. Cool. So, it is almost the same as we can do with an array, right? Except that we can add, right? Could we do a normal for loop? How would it look like? I less than what? What is normally our thing in the array? If we have an array, what do we do? Yeah, an array we go till length, right? In this, it is size. If we had an array, what would we do? We would do words of I, right? Since it is not an array, it is a list, we have to do dot get I. Other than that, it's the same thing. And so we are going to see 1, 2, and then 1, 2. Does this make sense? Any questions? It's all cool. It's incredibly easy to understand. If I have an array, I can do int numbers, right? If I have a collection, I don't need to specify this size because I can grow it, right? I cannot do this. Java doesn't let me do collections of primitives, only arrays. So I need to use the box class, right? What was the box class for int? Integer, cool, with a capital I. Yeah. I could use add, or I can also use arrays dot as list and then pass elements. So I could, let me eliminate this. I can still do numbers.add. Java, since version 6 or something like that, has auto-boxing and auto-unboxing. So it knows that you put an int, but you really wanted an integer. So it will automatically convert it to an integer. And if you are taking something out, it will automatically get it from there. So if we were to run these things, we would get 1, 2, 3, 4, 10, right? And we could do, how can we increment each number by 1? What would it look like? Oh, never mind. If we do it this way, it's just, oh. This wouldn't work, right? Because I cannot change an integer. Now this wouldn't work. It's gonna complain terribly. Yeah, well, don't complain. Just doesn't do a thing. Just increment that number, but doesn't change it in the array. We would need to use a for loop. And then how do we express, right? How would we do it if it was an array? If numbers was an array, what would we do? Numbers sub I equals numbers sub I plus 1, right? So how do we do this piece being a list? Numbers dot, well, that piece is numbers dot get I, right? That's the equivalent of this, right? Just this piece.
You mean without the plus 1?
Without the, oh yeah, never mind, yeah, plus 1. Yeah.
Yeah.
And then I'm going to do numbers dot set I, comma, numbers dot get of I plus 1. Syntax is horrible, but it's not that terrible.
Why you don't need to use number.get in the print statement?
Because I'm using a for each loop. I'm not going through numbers, I'm going through the elements. But that way I'm not allowed to change the elements. I am in an array, but not in a collection. Because collections are almost usable, but not quite.
But to print strings, you need to use a dot.
If I don't change I could do it either way, right? I could use numbers.get and iterate over the numbers, right? When I'm here, my I is going to take the value 0, 1, 2, 3, and 4, right? Whereas on the second loop, the number takes the values 1, 2, 3, 4, 10. It actually goes over the elements, not over the indices. Does that make sense? So, but it doesn't allow me to, it stores that doesn't allow me to change. It doesn't allow me to change the references when I'm doing that. It does allow me to call a method on the object, but it doesn't allow me to change the object the reference in the array refers to. Which is what I would need to do because integers are immutable. I cannot change the value they contain. So I need to do it this other way. So if I were to run this thing now, I'll get 2, 3, 4, 5, 11. if I had an array of points,
So you changed the list, or have you changed just the output?
what do you mean?
Have you changed the elements of the list?
Here, yes,
Or
I have changed now in the slot 0. I have a new integer
Okay.
that has that value. It's a completely new object.
Okay. So it's not only the output.
Well, no. I'm just printing what is in the array. So I changed the elements in the array. In fact, this would, I don't have to, but this is what I'm really doing. Except that Java does auto-boxing and unboxing. So since I have to do that, I have to use a set. So, what do we prefer? Lists or arrays? Which are better?
What do you have to do, I guess?
Depends on what they have to do, right? Good. That's the answer to 80% of the questions in this class. Except not on the test. It depends. Please write a code that does this. It depends. No. What's the advantage of using an array?
Well, what comes to mind immediately is how inherently built in and how structured and organized it is for me to deal with all one type of object.
It is built in, and what does that mean?
In my case, the less things I got to figure out as I'm setting them up.
The syntax is
Yes.
nicer, right? That is what it really gives. The
And at my
syntax,
stage, that's a big help.
which is a big help, especially when you're starting, right? The other thing that it actually gives you is that they tend to be fast. Because this thing is implemented with an array. So, an array will be fast. What does this thing give you? Flexibility. What's the big thing? They can grow, so you don't need to know how many you want at the very beginning, right? I could ask the user for numbers and put numbers inside, right? And I don't need to make, to decide how many. I could have a game info object that can contain more than 10 reviews. Isn't that cool? That's actually assignment 10, by the way. Or a big part of assignment 10. Yeah, actually assignment 10 is basically assignment 9, but with collections. With an extra thing for, but. So do we understand arrays reasonably enough? Or lists? When I do functions, right? When I do functions, I want to pass a list. I could pass an array list and it would work, right? However, I could decide that I want a different kind of list that's not an array list. The interface is list and it defines all those methods. An implementation class is array list, but there is other implementation class. Which, yay. Array list is the obvious one, but there is linked list. And I could do the exact same thing, right? I can just replace this with linked list. oops, linked list of integer, and it would work. Did I include it here? It did it by magic. So by using the interface as much as I can, I make my code slightly more generic. It's more a matter of style than anything else, because in Java, you're going to be using array list. But just in case you want to use something else. Does that idea make sense? So I can pass it to functions, I can do everything else, right? So are we reasonably comfy with lists and array lists? Yes?
What happens if you delete an element on the middle of the array?
Yes.
Does that spot stay empty, or does it?
No, it moves everything. And so actually, Java allows me to do that. So let me do this. Let me change this for now to list all of integer. Yeah, this is horrible. Sorry. I can call print all public static, or really just static. So I can do this and print all the numbers. But then I can also do remove and pass the index. So let's remove this guy. The element with value 3. What's its index? 2, right? So if we print it again, we first get it, and then now it's not here anymore, and everything else gets moved. Does that make sense? So that's another nice thing that the list class gives, list interface gives us, that the array interface doesn't. By the way, other implementations of the list include the stack, which basically adds push, which is the equivalent of add and pop. And we also have a queue class. You don't tend to use stacks that much, but a stack puts things like if you're putting them onto a stack. So when you remove one, you remove the last one you put, which is called last full, last in, first out. If you have a queue, you remove them as in a line, right? Queue is just fancy British for line. So fancy English for line. But they actually use the word queue, we don't. So you remove the first one you entered as opposed to a stack. Where is my queue in? Is it not a list? Oh. Oh. Because they extend collection but not list. And the difference is that I don't have the get and set, so I can only add that way. I also have a set interface that is mildly useful. Actually, sets are fairly useful. They behave sort of like a collection and a mathematical set, right? So you can add an element. If it's already there, then it won't be put there. How does it know if the object is there or not? You defined an equals method, right? If it's your class. But we will probably only use the list interface, and you probably want to know that set exists. But we may do some cooler examples next session. Now, if you don't have any more questions about array list or any of the other collections, let's talk about maps. Maps are cool. Maps allow me to have whatever I want as my key. With a list, I still have ints as my key. With an array, I have with a map called a dictionary in other places, I have whatever I want as my key. So I can have, as in this example, a map from string to integer, and so I write the digits, right, as a word, and then map them to their actual value. And then I can do this. Digit values.get of 1, and that will go find over there the value that corresponds to 1. Isn't this cool? This is the coolest thing in SlideSpread. Actually, a lot better than SlideSpread, because SlideSpread. But it was a lot better than StateSpread, which was what existed before.
So, is that how you use with non-relational database?
Yes-ish. Yes. There are actually, you use relational databases by using relational databases. But this allows you to do stuff that looks more like a database. So when you use a relational database, at the kind of lowest level, what you get, a record that you get from a query would be one of these. Right? That maps the column names to the values. And then you actually get a list of those. Sort by kind. Normally there's 700 different libraries for doing it, and it's not quite that, but the basic idea is this. And some of you know databases or have a clue. Many of you will see it as one of your next classes eventually. We get almost the same thing. We get and put and remove. And then size is empty, but we also get key set, entry set, and values. Key set returns the set of all keys. Entry set returns, a set of entries, and values returns the actual values. So let me do this. Actually, before that, let me do one thing. Actually, first of all, collection is more generic than list. And so it really should be, if all I'm doing is iterating over a list, I should be using collection, right? And verify that this works. Cool. And then let me do one bit of magic. I messed up. Never mind. I think collection, but oh. Okay. It works with a collection. Then let me. Oh well, we'll do it next class. We'll use this, which is horrible, but that's okay. Let me paste that thing in here, right? I can do this. I can go over all the keys, right? This is a map from strings to integers, so my keys are strings, right? I mean, how can I get the value? It's stored in digit values, and how do I get the value from a collection, from a list? Yep. So in this case, it's gonna be the word, right? So if I run this, I get this stuff. 0 maps to 0, 1 maps to 1, 2 maps to 2, right? Is this cool or what?
It's in the order that we put it in?
There is no guarantee. And now this is cool, right? Because for maps, we have two very useful implementations, and both of them are very cool and very useful. One is a hash map. A hash map uses a hash table. What the heck is a hash table? Well, for each one of your elements, each one of your keys, you apply a function which is called a hash, and you get a number, and you have an array of spaces, and you try to put that element in that slot. It's super fast. You just transform something and go put it in there, right? Problem is when you have collisions, when there is already somebody there. And then there is 20 different algorithms for how do you deal with collisions, which you will see a couple of them in your data structures class. They are slightly besides our point. We may see them if you guys are interested just for fun, but they are not that complicated. Some of them are not complicated. Some of them are very complicated, but many of them are not complicated. Hash tables can be done tremendously fast. Maybe 10, 15 years ago, people came up with better algorithms for hash tables, and so now they are kind of the preferred implementation. However, they are not sorted in any particular way. It's just whichever way they happen to be entered into the table. So in this case, they actually worked, right? But I think it is by chance. Yeah. It's in whichever order they feel like it. Right? The 4 is in the middle. And that is by design, right? They just go through that table that they created, and the idea is that it's not easy to find. It's not easy outside of the hash table to figure out where would it go, to make it almost random, because that gives you better performance. The other one, and hash tables are very, very fast for many applications. They don't have guaranteed performance. So, if you're extremely unlucky, right, what would be really, really bad? That you happen to put 5 things in there, right, that actually all map to the same cell in your hash table. Right? You could be that unlucky, and that would mean that your hash table now became a linked list, and your access is linear. So your worst case in a hash table is terrible, your average case is super fast. Usually, you are not that unlucky. The other one is the tree. And balanced trees are guaranteed to be balanced. And so if you use a tree map, you are guaranteed logarithmic performance. And so this will actually be in order. They are in alphabetical order by the keys, right? They're sorted by the key, not by the values. Which one do you use, a tree or a hash? It depends, right? For 90% of the applications, it doesn't terribly matter. Why it doesn't terribly matter? Because to do anything on 1,000 things with a computer is obscenely fast. So if you're putting hundreds of things in your table, it doesn't matter, right? Now if you're putting millions or billions of things on your table, then it matters, and then you get to play and decide, right? But you're going to put 100 things, who cares? My default tends to be a hash, because usually they're faster. I love trees, I'm a databases guy. Trees are really, really cool. The advantage of trees is that they have guaranteed performance. So you know that it cannot be that bad. Whereas with a hash it could be that bad. Right? And you know that yes, you shouldn't be that unlucky, but you can be that unlucky, right? And you know when are you going to be that unlucky, right? When you're demoing to your boss, right? Actually, when you're demoing to your CEO. But normally hash tables are faster, so I tend to use them. I can usually get another job if my demo doesn't go bad. So. Isn't this cool? So now you have 700 collections and you can do all sorts of cool things with them. Isn't that nice? By the way, we covered a little bit of this when we covered objects, right? We did an equals method. For the collections to work, you need two things. You need an equals method if you define your own class, and you need a hash code method that will generate that number. So whenever you define your own classes, you should be creating a hash code method and an equals method. And let me show you the really ugly way of iterating over the complete set. If we do value set, we get the values, but if we do entry set, we get a set of entries. What the heck is that thing? It is a map dot entry of string and so that would make it lm.key get key, sorry. The syntax is ugly as hell, but this should be somewhat faster because it's doing both of them at the same time. Isn't this cool? Let's do some. Sorry? They print the same thing. Yeah. There's this one, and then this one. They are completely equivalent, or they should be equivalent. Many times you end up with these collections combined all over, right? So it's fairly normal to have lists of maps or lists of classes, and this class contains a map from this to that, and this class, right, the that contains a list of thises, and all of that stuff. So play with these things as much as you can. One of the standard ones that I do, since we have time, let's do an example. So get a list of words and calculate the frequencies. So now we're going to create a map that says this word appeared 7 times, this word appeared 10 times. Does that make sense?
Mhm.
So how can we do that? Well, first of all, we probably want to create that thing, right? Equals what? What happens if I do this? Can I do it? No, because map is an interface. So I get some horrible thing. Yeah. It's abstract and cannot be instantiated. Right? So what do I need to do? Use either a hash map or a tree map. Which one do you prefer?
Surprise me.
Cool. I'll use a hash map. Because they are cooler now. So I need to iterate over all the words, right? So what can I do? How do I iterate over a collection of things? By iterating over a collection of things, right? So now, what do I need to do, right? What do I want to do here? I'm hoping that I'm not doing the assignment, but what I really want to do, right, is words.set words.get right? Oh, wait, not words, sorry. Not words.set, but frequencies.set, right? What? Oh, put. Of course. Sorry. Does that make sense? I go to every word, through every word, and I add 1 to its frequency. What's the problem with that? That would almost work. What happens if the word isn't there? Exception or some horrible thing, right? So I need to verify that it is there. One way to do it is by using contains key. So if it contains it, put it, otherwise the magic of autoboxing and unboxing means that this gets transformed from an integer onto an int. Then I add 1 as int, and then it gets converted back into an integer before it's put in, and this 0 gets converted from an int onto an integer, right? But this should work. Now we can start doing magic. Or actually, split will split a string and return an array of things, but I need a list. Actually, can I do, let's see. Would this work? Running to call horrible things. Yeah. God, how do I convert an array to a list? Arrays.asList, not to list. So split breaks by spaces, and so it gets 1, 1, 1, 2, 2, and that gets transformed into a list, right? And so if then I need to do map of string to integer static, right? So this would print 1 map to 3 and 2 map to 2. Oh! So our function is wrong, right? Oh. What's the problem? Do you see it? Computers are like that. They'll do what you tell them to do instead of what you mean. Oh, yeah, if I see it, I should be adding 1, right? Rather than 0. Isn't this cool? So this was our function. That one tends to tie in together very nicely what that list versus a map. Any other questions? Now, your assignment 9 is same, or assignment 10 is the same as 9, but with collections. Or there's a couple of other things added for math or something like that. And we are almost done with our required content, and then we'll go have fun. Cool. Happy Halloween. Get lots of candy. I'll see you guys on Wednesday.